Hello, I'm back. Maybe it's been days or weeks, hopefully not, since you watched the other infrastructure videos. Probably you didn't mean to watch the sewer one before this one, but hopefully you watched the kind of the overview video of the economics of deciding how big to make things. Okay, so today, or in this video, we're going to talk about highways, and bridges have the same basic concept. So bridges are even better because they're sort of a constriction point, and you don't have to worry about people going around places where you might want to charge them for being in the road at high capacity times. Because while that might help the road be less congested, it'll just turn something else into being congested. All right, but anyway, so highways and bridges is the subject of this video, and remember, the fun never ends unless you let it. Don't forget that. This is serious academics with a sense of humor. All right, so what does the model look like in this case? Well, we have our standard peak and off-peak situation, right? There are rush hours. Not everywhere, of course, but most urban areas, more people work and live in some areas than others, and so there's a sort of a directional flow, and maybe the roads are just uniformly kind of on the small side because of funding, and so, at certain times of the days are clogged no matter which direction you're going. All right, so if we want to take account of the way things look highway-wise in the sort of intermediate run, just to save on drawing more lines on the graph, okay? All right, the supply would look something like this. Okay, so we see right away what the graph says, and that says if you charge a price at P prime, which in other words would keep the highway large enough to handle the capacity during off-peak periods, right? Off-peak demand, off-peak right there. Okay, well, A versus B is the shortage that you'd have at rush hour. In other words, how clogged the highway would be, how many vehicles you'd have, too many, to let the traffic move along at a reasonable speed. By the way, see, those are all assumptions there. What do you mean by a reasonable speed? Suppose you were using congestion fees, pricing, as a way to allocate the highway space. Well, do you want it to move along at 50 miles an hour? 55? 60? 65? See, that'll all determine how many vehicles the highway can handle, and thus what you would charge as a fee. All right, so just kind of keep that in the background, but we don't want to be stuck in traffic. We don't want to be just crawling along. Okay, so whether the fee is set to be moving us along at 50, 55, we'll leave that for another time. But see, that's one of the reasons a lot of these things are full-time jobs for folks, is to figure out all of those issues and how all those interact and how they keep changing as new things are built and ways of getting around change. All right, so a big traffic jam at price P prime, say maybe the result on a freeway from just charging people gasoline taxes to drive. That might be the basis for P prime. Okay, now what happens if you build something sort of in the middle here? Okay, so now if you have P double prime, okay, sorry, I'm talking to my graph. You have P double prime there. You see this little spot here right in the middle. Okay, you'd have that, and then you'd have E versus C as a shortage in peak periods, and E versus G, okay, as a surplus, kind of lonely out on the highway during the off-peak periods as a result of charging that price. And if P prime represents the result of gasoline tax, then P double prime, you'd have to have some sort of a congestion fee charged to the people that are actually on the road at that particular time. All right, so what does this mean in terms of our pricing and efficiency and all of that? Well, if we want to make sure we have a freeway, which means no additional charge beyond the gasoline tax for driving on the highway, then to have people moving along, we're going to have to supply quantity at point B, right, to keep traffic moving along. Well, you can see, without me having to draw it on there, well, I'll draw a little bit on there. At point B, the marginal vehicle on the road, which is every vehicle, because any vehicle leaving, right, it's the marginal vehicle or arriving. We have the area where the letter C is sitting, right, between the supply line and the peak demand line, as a deadweight loss. Right, the marginal vehicles past point H, the additional value to that driver being out on the road between A and H, between B and H. Right, so I'm getting kind of messed up by being backwards. Okay, so kind of a mirror here between H and B. The additional value to drivers of being on the highway at that time are less than the additional costs. Okay, so that would be a deadweight loss area in there. So what we should do from an economic efficiency perspective is charge at point H. Okay, so we should charge a fee equal to the difference between P prime and P sub OP for, I've been doing this too long today. I'm at price peak, okay, the P with the P subscript, okay, at point H is what we should charge. The double-headed arrow indicates the congestion fee we should charge in order to have only Q sub H lanes instead of Q sub B lanes, right? H versus B. Think of what that means in a lot of urban areas. 2 or 3 or 4 additional lanes to keep traffic moving at rush hour versus charging everybody a small toll so that some will travel by other means or at other times, and those who have to be there on the road at that time get where they're going at 50 to 60 to 70 miles an hour. Okay, so that's the issue here. And with electronic tolling, it's no problem to levy that toll without creating the congestion at toll collection plazas. Those are completely defeat the purpose in many cases. Now, there's places where they have toll plazas on the roads that are uncongested because it's a private road. They've got to collect the toll even at off-peak periods. See, that's the efficiency issue for highways and bridges. They should be free at the margin, no additional charge beyond whatever you use to pay for them with, because they're quasi-public goods. At off-peak periods, there should be no additional charge to use the road, right? Because there's no congestion, there's no rationing by price needed. Okay, so they should be freeways at off-peak periods, but not during peak periods, because then there is an opportunity cost when you get on the road. And it turns out, by a more elaborate proof than I'm willing to provide to you, the optimal toll, what's needed to ration out what's available, builds the optimal highway, because you see the additional revenues generated by the toll allow the construction of the additional lanes needed only by the people that are on the road during those peak periods. And it guarantees the availability of those lanes to those people, whereas the building big freeways relies on politicians competing for limited funds to build roads in some places and not build them in others, or to levy huge gasoline taxes to build roads out here at point B, right, where the additional capacity from H to B is worth a lot less than it costs to produce. All right, so thanks. Moving on to a couple of others here in a minute, a couple of other infrastructure issues.